Welcome to VW 3.2. Today we're going to be doing a little bit of graphing and we're going to talk about symmetry. So our first question here says find the x and y-intercepts of the graph. So let's separate it. We'll do x-intercept first and we'll do y-intercept second. Recall the x-intercept, you simply let y equal to 0. So let's do that. And we solve for x. So x squared is 4. Don't forget that this is the absolute value of x, and that will then generate plus or minus 2. So there's your x-intercepts. For the y-intercept, you simply let x equal 0. So you plug that in, and we get negative 4. For graphing today, you can just sketch it. So I didn't provide you a graph because you don't got to be super accurate. We'll just do a rough sketch here. We have our x-intercepts as 2 and negative 2, so we'll label that. And our y-intercept is 0, negative 4. And for points, that will be enough, because what I want you to be able to do is look at this function and think, oh, that's a parabola. I see an x squared at the front, and then sketch your parabola. And that will be fine. Now let's go to symmetry. Given the point AB, find the new point given the following. So to make this easier, I'm just going to assume that AB is in quadrant 1. And it's not really necessary or important, but it will make it easier for me to do this question. Your other questions have numbers on them, so you won't need to make any assumptions like this. But for us, it'll make it a little bit easier. So we'll generically just put AB right about here. So we're going to do part A, reflect over the y-axis. I'll do this in red. The y-axis is right here, so we're going to put our point right about there. That's part A. Now think about what happens. If you reflect over the y-axis, the y value doesn't change, so our b is identical, but the x value would negate. So there's part A. Part B I'll do in blue, reflect over x-axis. So x-axis is right here. We're going to reflect over it. So the point should be right about here. And if you reflect over the x-axis, the x value should stay the same, so A, and the y value would negate. That's it. Last part we'll do in green. To reflect over the origin, you simply reflect over both the x and y axis. So that point should be in quadrant 3. We'll see it's right about here. That's part C, and again, they are both negated. Now we need to go over that to do this final part. We're going to apply what we just talked about to an actual function. There are 3 tests we're going to go over today. There is the x-axis symmetry test, the y-axis symmetry test, and then finally the origin symmetry test. To do this, we're going to write let right here. That's going to be our starter. And what I want all of you to do is to highlight this original function. We're going to call that your OG function. That's your original. So we'll be referring to that constantly. So the x-axis symmetry test, what you do is you simply let y equal negative y. Now, if you think about it, let's look back up here. If we're testing for x-axis symmetry, that was part B, if the y value negates, notice how the x value shouldn't change if you have x-axis symmetry. So what we do is we're going to plug in negative y for the y value and see if the function changes. So let's plug it in. Negative y equals 4x squared over x squared plus 1. Notice how this thing does not equal your OG function. If it were equal, that would tell you it does have symmetry, but it does not. So therefore, there is no x-axis symmetry. Next part. For y-axis symmetry, if you think about the y-axis, look right here. The y stay the same and the x negates. So what we're going to do is we're going to say let x equal negative x. And again, we're seeing if the function changes. So plug it in. And some of you might be noticing what's about to happen. Notice how when we simplify this, the negatives go away, and this is equal to your OG function. That means the negative didn't matter, and our conclusion is there is in fact y-axis symmetry. So you want this to happen. When this becomes the original function, that tells you there is symmetry. And for the last one, origin, if you recall what we did here, we're reflecting over both x and y. So for origin, we're going to let y equal negative y and x equal negative x. So you just put the two tests together. Negative y is equal to 4 times negative x squared over negative x squared plus 1. Negative y equals 4x squared over x squared plus 1. Again, we can see this is not the OG function. Therefore, there is no origin symmetry. So y-axis symmetry is the only type of symmetry this particular function has. And that's it. So good luck on the rest of the questions, and bring any questions you have to class.